radians. And the arc length is 12. Now, you are looking at this thinking, oh my gosh, I don't have a clue what any of that means. And that's okay. Let's talk about what it means. When we measure angles, up to this point in your life, when you have measured an angle, you have probably done it in degrees, right? You've said this angle is 18 degrees, or this angle is 30 degrees, or 100 degrees, or something like that. Well, you know how if you took out a ruler and I said, let's measure this desk. You could measure this desk in inches, but you could also measure this desk other ways. How else could you measure this desk? Not just inches, you could measure it in centimeters. You could measure it in feet. I mean, there's lots of ways, right? Lots of units of measurement. The same is true with angles. The farther you go in mathematics, the less you're going to use degrees. And the more you're going to use an angle measurement called a radian. Now, you might want to get out a sheet of notes and take some notes too. A radian is the measure of the angle determined by striking an arc of radius length. So that's what a radian is. A radian is a measure of the arc, or excuse me, the measure of the angle determined by striking an arc of radius length. So, if I have a circle, if I have a circle, and let's say the radius is 6 inches. If I lay a piece of string 6 inches long, radius length, around that circle, that's the arc. It's the same length as the radius. Do you see how that the end points of that arc determine an angle? That is 1 radian. So if I took that very same circle, but I struck an arc that was 12 inches long, how big would that angle be? 2 radians, wouldn't it? What if I took that very same circle and I struck an arc that was only 3 inches long? Okay, now wait a minute. 0.5 or half a radian? You are discovering a very special relationship between the arc length, the radius, and the angle measure. Can you tell me what that relationship is? When the angle was 2 radians, the arc length was 12. How did you get that? 2 6s? When the arc length was 6 inches, the radian measure was 1. When the radian measure was a half, the arc length was only 3. It looks like the arc is the radian measure times the radius measure. Would you agree with that? That is a really important formula. Your book will write it like this. I remember it better thinking of it as radius times radians. But theta, this is a Greek letter theta, that is the measure of the central angle. And R is, of course, the radius. S is the letter they use for arc length. So if you're reading your book and you see S equals theta R or S equals R theta, Or, Jake, you're an IB student, you have your handbook, I don't know if he's made you familiar with it yet, but you have a little booklet of formulas. That formula will probably be written this way in the formula book. Arc length equals radius times radians. All right, so with that in mind, can I answer question 1? I'm looking at the front of the quiz here. Can I answer question 1 on the quiz? Find the radius given the central angle is 1.5 radians and the arc length is 12. So you have a circle. The arc length is 12. The central angle is 1.5 radians. And your job is to find the radius. Can we do that?
Yeah.
Yep. What will our formula, what will our equation look like? 12 equals 1.5 r. So r equals 12 over 1.5. Now this is a no calculator question. So you might think of that as 12 divided by 3/2, which is 12 times 2/3, which is what? 8 centimeters. If your arc length is in centimeters, your radius is going to be in centimeters. They're going to have the same unit. All right, skip down to question 2 on the quiz below. It's the same question. Find the arc length given the central angle is pi over 7 radians and the radius is 10 feet. Find the arc length given the radian measure is pi over 7 and the radius is 10. Don't I just multiply pi over 7 times 10? And the answer is 10 pi over 7 feet. Remember, the measure of, or excuse me, the unit of the arc will match the unit of the radius. Got it? Easy. All right, now look at the other 2 questions on the front side of the quiz. They involve changing degrees into radians and changing radians into degrees. Now, didn't you spend half your life in chemistry doing this? Changing from one unit, well, not degrees and radians, but changing from one unit to another one? I mean, don't they have you do that all the time? Yeah. So we just need to figure out what's the conversion for degrees to radians and vice versa. Well, it's very simple. 1 revolution is 2 pi radians. In other words, all the way around the circle is 2 pi. Well, how many degrees is all the way around the circle? So 360 degrees is the same as 2 pi radians. You can use that conversion, but most people reduce it and say 180 degrees then would be 1 pi radians. So in other words, half a circle is pi radians. So question number 3, I'm looking at the top quiz. I know that 180 degrees is pi radians. And I want to figure out 200 degrees is how many radians? Right? So you can set up a proportion. You can set it up exactly the way I wrote it if you want. I don't normally set it up that way. That'll work. That will work. I normally set it up pi over 180 equals x over 200. That's my favorite way to set it up personally. Here's the deal. Pi and 180 are the same. Would you agree? So these are the same. That's a match. I want to know what will match 200. So I say pi radians is 180 degrees, so how many radians are 200 degrees? How would I solve that? I'm just going to multiply over here this 200. So x will equal 200 pi over 180. Just bring that 200 right over here. And then I'll reduce. So how does that reduce? 20 over 18, which breaks down even more. 10 pi over 9. Let's jump down and do the one at the bottom like that. That would be number 1 on the bottom quiz. Can you change 310 degrees into radians for me? You can set up your proportion any way you like. I mean, as long as it's legit. I'm going to say pi is to 180 as x is to 310. Now, why do I have the 310 on the bottom of my fraction? Because 310 is a degree, so it's got to be in the same spot as the degree. This is pi radians, 180 degrees. So, you got an answer yet while I'm standing up here talking? How about, let's reduce it. It looks like 31 pi over 18. Is that okay? All right, now let's go the other direction. Let's look at number 2 at the top. We have 4 pi over 9. Now that's a radian measure. So I want to know how many degrees that is. Do you think I could set up a proportion like this and say pi over 180 equals, what would this look like over here? 4 pi over 9 over x? Could I do that? I sure could, but there's a shortcut I want to show you and hopefully not confuse you. Pi, just pi, is how many degrees? 180. So what would pi over 9 be? 20. And what would 4 of those be? 80. That is 80 degrees. Now, how did I do that? I recognize that 4 pi over 9 is 4/9 times pi. And since pi, I already know pi is 180. That's a given. That will never change. That's fact. Pi is 180. What I'm really doing is saying, okay, what's 4/9 of that? So 180 divided by 9 is 20. Times 4 is 80. Can we do the bottom one that way? 5 pi over 9. What would 5 pi over 9 be? Well, pi is 180. Remember, I have no calculator here, so I'm trying to do it as easy as I can. So a 9th of 180 would be 20 times 5 is 100. Now, before we turn it over and go to the calculator, I want to do one more problem. This one you cannot use the shortcut on. So this one we'll have to set up and do some work. What if we wanted to change 2 radians into degrees? Now, if that were 2 pi radians, it'd be 360. I'm done. But it's not. It's 2 radians. No pi. Just 2. What do you think I'm going to have to do? Set up a proportion. Pi over 180 will equal what? 2 over x. Bingo. That's it exactly. 2 over x. Pi radians is 180 degrees. So 2 radians is how many degrees? Now when I cross multiply, pi x equals 360, and x is 360 divided by pi degrees. You can use this proportion every time to change degrees into radians and radians into degrees. It'll work every time. The shortcut is nice because it goes faster, but you never have to use a shortcut. You can always use this proportion. Chandler?
If pi is 180, will it reduce?
No, because when you're talking about when your answer is in degrees, pi is actually 3.14159. So this is closer to 120. Yeah. Great question. Okay, ready to turn it over? Let's get our calculators out, because now we're going to do some stuff on the back. Well, first we can do the number 6s. The number 6s are just making sure when we draw an angle of negative 100 degrees, it is imperative that everybody draws it exactly the same way. Because when we start finding sines and cosines and secants and all that stuff, where we have the angle drawn will determine whether those things are positive or negative. So there is one place, we're not going to argue about it, you don't get to pick. There's one place where you draw a negative 100 degrees. When we draw an angle in standard position, we always start measuring it from the positive x-axis. This is what we call the initial side of the angle, the starting side. If the angle is positive, we rotate up, counterclockwise, we go up. This would be a positive angle. If the angle is negative, we go down. So our angle is negative. So we're going to go down, and we're going to go 100 degrees. Now, how far do you think it is to here?
180.
Oh, that's not 180.
90.
That's 90. Kids, all the way around is how much? 360. So 180 would be over here, right? So this is negative 90. So I actually got to go a little bit past that. There would be a picture of negative 100 degrees. It is in the third quadrant. And in the third quadrant, x and y are both negative, which means your sine and cosine are going to end up negative in the third quadrant. All right, so quick review. When we draw angles in standard position, where do we start? Positive x-axis. If the angle is positive, we go up and around. If the angle is negative, we go down and around. Got it? Okay. The other way we draw angles, and I really don't know why they don't match. I'm sure there's a reason. I've just never researched it. But the other way we draw angles is when we're talking about navigation. When we're talking about giving directions or giving a course of something. Number 6 on the bottom quiz says, draw a course of 211 degrees. Now, that means you got an airplane pilot and you're telling him to fly on a course of 211 degrees. That is different than standard position. A courses are always measured from due north. They start due north and they go clockwise. So this is 90, this is 180, this is 270. So if somebody wants you to be on a course of 211 degrees, we start at due north and go clockwise. Where are we going to be? A course of 211 degrees. Where are we going to be? Right here, aren't we? This is a course of 211 degrees. This is 4. How do I know when I start straight up, and how do I know when I start on the positive x-axis? If the problem is navigation, if it involves giving direction, airplanes, boats, cars, anytime you're giving any kind of direction, you start due north. Every other angle you ever draw in any math class ever is going to start on the positive x-axis. The only exception is navigation. Okay, so quickly, one more of each. If I just said, draw 200 degrees. If I just said, draw 200 degrees, see if you can do that real quick over to the side. And then if I said, draw a course of 200 degrees. Draw that over to the side. Is that what your pictures look like? Pictures okay? Any question? You good? Okay, then let's get the calculators out and let's do this, and then you can go to lunch, right? Isn't this the lunch period? I think it is. Okay, so here we go. Number 1 on the back, top, number 1, says change, oh my, what is all that? 114 degrees. Anybody know what those other little subdivisions are? 18 minutes and 13 seconds. You know how an hour can be divided up into 60 minutes? And each minute can be divided up into 60 seconds. Degrees are the same. So there are 60 minutes in a degree, in an angle degree, and 60 seconds in every minute. Okay? So here we go. How are we going to do this in decimal degrees? Oh, you have a wonderful calculator. Get it out. All right, got it turned on. We're going to press 114. Everybody got 114 pressed? Now, if you press your angle menu, so you need second angle, and for me, it's the apps button. Is it the apps button for you? Angle? It's a second function. Find it? Okay. Notice the very first thing there is a degree symbol. Press enter. So now does your screen say 114 degrees? Okay. So now we're going to type 18. And then we're going to go back into our angle menu and see how the second one is the minute mark. So click down and press enter. So now the screen says 114 degrees and 18 minutes. Okay, so now we put in 13. All right, now here's where things get wild and wacky. Do not even ask me why this is. But the seconds button is above your plus sign. And it's, for me, green. I don't know what color it is for you. So I have to press my alpha plus, and that pulls my seconds up. So now you should see on your screen 114 degrees, 18 minutes, 13 seconds. If you press enter, it gives you the decimal value of that degree. So the decimal degrees, 114.3036, whatever directions you're given for rounding.
What is the that one again?
It's above the plus sign. Right above the plus sign. All right, now let's go down and do the one at the bottom. That would be number 5 on the bottom quiz. So here we go again. We start out by pressing 77, right? Now, where do we get the degree symbol? Angle. It's right there. And then we want 18. Where do we get the minute symbol? go up. And then we need 32. That's when you go to alpha plus enter, and what did you come up with?
77.308.
Yep, 77.3089 if we round it off to 4 decimal places. Okay, so that's how we get decimal degrees. We literally type in whatever degrees, minutes, and seconds they give me, and out will pop the decimal value. Now, how do you go backwards? Well, let's go back up to the top. Number 5 at the top says change 4455 into degrees, minutes, seconds. Okay, so I want you to type 44.55. Go to your angle menu and notice that one of the options is DMS. Guess what that stands for? Degrees, minutes, seconds. Press it, and it will say 44 degrees, 33 minutes, and 0 seconds.
But you want us to write 0 seconds or create it?
You don't have to write 0 seconds, but I said it because that's what happened. All right, so let's go down to the one at the bottom. 89.57. All right, all we do is press 89.57. Then we go into our angle menu and DMS it. 89 degrees, 34 minutes, and 12 seconds. One more comment before you escape for lunch. There are some problems that will say things like round to the nearest minute. So if you got an answer like 89 degrees, 32 minutes, and 12 seconds, rounded to the nearest minute, that would be 89 degrees and 32 minutes. Remember, how many of these are there? 60. So if this number of seconds is less than 30, you're going to round down. If it's more than 30, you're going to round up. It's just like a clock. There's 60 seconds in a minute and 60 minutes in a degree. So if I said round this to the nearest degree, it would go up to 90 because 32 is more than half. 30 is half. Okay? All right. Let me see what I want you back. I want you back in your seat at 12:25. In your seat at 12:25. You can leave things here. If I leave, I will lock the room. Okay, I'll keep you. Yeah.
Sitting down.
Yes. Yeah.
That's the normal time to get out.
Escaping. You're getting out? Escaping? Okay, so I have no idea. Okay. Whatever. But they needed to get me to move. And without disrupting the schedules real tight because you're not thinking that's how long, right? So this is the best fit for you right now. There's no other class that you can move into. So I know you're coming from honors. I know this is academic. I don't know if this is just till the end of the semester, which is basically only 3 weeks or something, or if this is for the rest of the year. I have taught honors curriculum. I have no issues with having. I talked to Mr. Thompson about you. He said this class is probably going to be kind of easy for you because you are so good. But there's some stuff you're going to learn, and so I need you to buy in, be participatory, and whatever. If at the end of the semester, if they can get things worked out, move you back, it'll be fine. We are actually ahead of the honors class. We almost always are. We've tested over chapter 3, so you are missing a little bit of information in there that we will have to figure out how we're going to get that in. But you're on your way to chapter 4. He's going to start chapter 4 soon, so it'll be good. If we're going to move you back to the honors class, and again, this all just happened real quick, so I don't know any details. If we are going to move back to the honors class, I will get his assignments and have you I mean, I gave you an assignment sheet. Those are the problems that was on that purple sheet I gave you. These are the things I expect you to do. But if you're going to be going back to the honors class at some point, then I will make sure you are doing the honors homework, which a lot of times overlaps, but obviously, so we'll work on that. But what I need from you is total income. I have no idea, but it couldn't have been good. I mean, this kind of crap just doesn't happen. So I need total income